Alright, we started example 6 in class, but we never got a chance to finish it, so we're going to go ahead and finish it up now. Example 6 said, which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? Closest is referring to a minimum value, and here's 0, 2. We're trying to figure out where on this parabola would a point be that is closest to 0, 2. So I picked a random, I called it xy point, and said that if this point is the closest distance, then I could use the distance formula to figure out how far away it is. So I don't really know where xy is, so I'm going to generically say I have a point at 0, 2 and xy and plug it into our good old distance formula. So you subtract the x values, x minus 0, subtract the y values, y minus 2, and square them and add them together for the distance formula. I am going to try and minimize this, so I'm minimizing distance, and minimizing distance means I'm going to derive it. With two variables, x and y, that doesn't really work well for me. So since y equals 4 minus x squared is the name of this parabola, I'm going to substitute that in. If y equals 4 minus x squared, I'm going to change this y to 4 minus x squared down here. Now distance equals this whole thing. X minus 0, I just called it x squared, plus 4 minus x squared minus 2 squared. So this is the thing we want to minimize. So I'm going to clean it up as best I can. I'm going to go down here and do another step. Distance equals. And I'll simplify this. This is x squared plus quantity. Let's make this 4 minus 2. Let's make this 2 minus x squared squared. And then to clean this up one more step, I'm going to have to take 2 minus x squared and FOIL it out. That's 2 minus x squared times 2 minus x squared. So I'm going to do a little bit of FOILing and combine it with this x squared. I'm going to skip a step here and just assume that you guys can kind of jump up with me on that one. Clean up the inside, multiply this all out, add it all together, and you get x to the 4th minus 3x squared plus 4. And now comes the next part, deriving and figuring out the minimum value. If this is what I want to minimize, then I need d prime. But if I'm going to get d prime, it's going to require a radical rule. It's going to be kind of ugly, to be honest. So I'm going to make a special note down here. D is going to be the smallest. So I'm going to write d is the smallest. D is the smallest when the inside is the smallest, when x to the 4th minus 3x squared plus 4 is the smallest. So if I want to minimize d, then I want to minimize the inside. So to make this problem easier so my derivative is nice, I'm going to say let f of x equal the inside, x to the 4th minus 3x squared plus 4. You can call it f of x, g of x, you can call it whatever you want, but that's the thing I really want to be the smallest. So I'm going to use that to get my derivative and my critical points. I'm going to derive x to the 4th to 4x cubed minus 6x. I'm going to set it equal to 0 and do some solving. And not too hard to solve. I'll factor out like a 2 and an x on this thing. So I'm going to have 2x squared minus 3 left over. And since they're both equal to 0, I'll split them apart. I'll say, okay, 2x equals 0 or 2x squared minus 3 equals 0. And we'll just solve them. This is going to be divide the 2 away. This is going to be x equals 0. And then on this side, if I add 3 over, 2x squared equals 3, divide the 2 away, and then take the square root of both sides, x is going to equal the square root of 3 halves, plus or minus, technically. So these are all my critical points. Negative square root 3 halves, positive square root 3 halves, and 0. And so I'm going to take all 3 of those points and place them on a number line and decide which one's a max and which one's a min. So here's my number line. We'll have negative square root 3 halves right there. We'll have 0, and we'll have positive square root 3 halves. Sorry, this is a little messy. And then I'll label it carefully. The top part is going to be the sign of my derivative, which we called f prime, so sine of f prime of x. And the bottom part is going to be the behavior of f of x. Behavior of f of x. So we got to plug in values. We got to find some numbers in between all here, these values that we can plug in. So it would help if we knew what the square root of 3/2 is as a decimal. So you might plug it in your calculator. It's going to be something real small. I'll do mine on the screen here. The square root of 3 divided by 2 is 1.224. So this is positive and negative 1.224. So if I had to pick something in between here, I could pick 1 and negative 1. And then over here, negative 2 and positive 2. And those are all the numbers I'm going to use to plug in and find the sign of f prime of x. So I need to find f prime of negative 2. Remember, this is f prime up here, 4x cubed minus 6x. This is what I'm going to plug all those numbers into, the derivative, to figure out if it's positive or negative. A nice little tool, a nice little trick if you want some ideas is you could go to your y equals and you could put the derivative in there, 4x cubed minus 6x. And if you put that in, I don't really care about the graph, but I could use the table feature. I could go second table, and I could type in, you know how I want negative 2 over here? I could type in negative 2, negative 1, 1, and 2. And you can see like right over on the side here, I get negative 20, positive 2, negative 2, positive 20. So those are my values. All I really care about is the signs. I got a negative 20, a positive, a negative, and then I got another positive. So I know my function's decreasing, increasing, decreasing, and increasing on this thing, making this value a minimum, this value a maximum, and the last one another minimum. So I have two mins and a max. And then you go back after all this work and you ask yourself, what's the question that I was supposed to answer? If you go all the way back to the top, our question was, which points on the graph are closest? We're looking for minimum values, and I found two different answers. So at x equals plus and minus square root 3/2, it's going to be closest on the graph. Now here's what that means. If we go back and actually look at our picture up here, remember I said I had to find a point closest to 0, 2. Well, that point must be at positive square root 3/2, and then over here it must be at negative square root 3/2. It really makes sense to have two answers just because of symmetry on this parabola. If this point is closest to 0, 2, there must be a matching one over here. Now to fully answer the question, get everything right, it says which points. It wants the x and the y value. So I'm going to kind of backtrack. Remember y equals 4 minus x squared? I really need to use that down here and say, okay, if y equals 4 minus x squared, and these are my x values, then y is going to equal 4 minus radical 3/2 squared. And y is also going to equal 4 minus negative radical 3/2 squared. And these will both turn out to be the same thing. I just need to plug those in and get some y values. So this is going to turn out to be positive 5/2, and so will this, positive 5/2. So actually my final answer is going to be in this form. I have 2 points. Negative square root radical 3/2 comma 5/2, and positive square root 3/2 5/2. And this is my final answer. These are the 2 points closest on the graph. You're going to notice on the homework tonight that the very first problem on the homework is pretty identical to this example. So use this example when you're doing the first problem. And hopefully that's helpful.